All in all, I wish you a very inspiring 2 days here and enjoy the environment if you have the opportunity here in Venlo. Okay.
All of the different web platforms that will be talked about over the next 2 days. So I'm quite worried that I got the first slot because everyone's going to be going, look, that's better. Right. Well, what is Aranya? Aranya is a dynamic web application platform. A lot of the systems which are in place, and several which will get talked about today, are static, which means that they are for producing websites which, essentially it's producing the HTML which will sit on the disk, be served by the web server. Aranya is an application that runs its fast CGI, which means that it's running all the time, and requests that come into the web server get passed to it for processing. Aranya is essentially a Lua VM with some changes and a very large dollop of support code on the side to help building these applications.
I like to pretend that as I'm standing in the bank line, I can write some really profound code that will change the world, and I don't really want to lug around a laptop or a desktop computer. So it's pretty bad.
Well, my name is Aswin Hirshi. I'm from a company named Reflexis. Let's see how this works. Yeah. I'll briefly talk about what we're doing because I think it's relevant to what I'm trying to say later on. We started about 7 years ago, and we do mainly software development. Well, basically all sorts of software development and consultancy in many different branches. So. And we have customers ranging from really small to really big. We do government work, we do, really commercial work, defense contractors, all sorts of industrial stuff. And it's fairly broad. Basically, the stuff we do comes in two flavors. It's either desktop solutions or web applications. And the good news is that we've been really active with Lua for the last 4 years. We started, I think I sort of stumbled upon Lua sort of beginning 2002, and we did some experiments over the summer, and we were also very pleased with it that we decided to do the next big project that came up with Lua. And we've been very happy with it ever since. So, but I think there is Lua the language, and I think it's I'm going the wrong way. And there are solutions that you'd like to give to a customer, and I think between Lua the language and something that you can throw over the fence to deliver to a customer, there's still a hole, a gap. It's a gap that you need to bridge if you really want to develop standalone systems.
When I read that Ansagen we heard yesterday with Context decided to incorporate Lua in Context, and that was for me the immediate decision. I would do the same, because if Hans is doing something, he has done a lot, and that has future. And from that time, I monitor the list, I gave him this little example, and I can just repeat his words. The more I got into it, the more I lost my fear, and the more fun I had, and I liked it. I started with just scripting, replacing my Perl scripts I never liked, because I don't speak Perl. I just copied from the internet and adapted. I replaced my batch files in building and had the fun of transferring all my Lua my stuff to Lua and get it really in control. In Primus, my application, I replaced all my configuration settings, ED, XML, and homebrew data, of course by Lua, which is reasonable, but you know.
Support for remote procedure call, or support for purpose subscribe. don't know if there are languages properly subscribed, but anyway, for specific paradigms. And then the nice thing about this is that you program in a well-behaved world where the language fits in very well with this specific paradigm. But the bad thing is that you are kind of, you have only this tool to work with. And then you have the possibility of combining the good things of both worlds when you work with reflection or with extension mechanisms. So if you have a language which allows you to extend it and seamlessly integrate new mechanisms in it. And this is what we explore. We've been exploring it a lot, both in research and in this course. So, for instance, usually I ask students to develop some RPC mechanism in Lua, and it's very nice because, of course, it's also very easy to, you can use Lua socket and easily create different models, like more rigid models where you have to obey an interface, or more dynamic things where you can find out dynamically if the method is at the other side or not. And then there's this thing that you can easily combine the things in one same application. So what are the nice things for us is the use of closures, so you can have the dynamic creation of remote remote functions, let's say. Also the idea of that you can redefine the behavior is important, because often we use the fact that the meta table, so that you can create this remote invocation mechanism only when you try to make the call, and also we use coroutines as well. So this is the first example. This is a very simple example because it's very near to that basic model. In this case, the only difference, I'll go to the slide, which is the Lua send. It's very similar to the basic Lua send, but now I send a name of a function I want to be executed at the other side, and the list of arguments for this function. But the nice thing about this is that it is very easy to write classical distributed algorithms with this library. Books on distributed algorithms usually use a notation which is event-based. So it goes like, if the event request comes in, do something. If OK to go comes in, do something. And one of the things I used to experience is that there is a big distance between this notation and other languages. So it's difficult for students to make the relationship between what the book says and an implementation. And so this is, for instance, a very well-known algorithm which is described in the Tannenbaum book on operating systems, where you go for distributed mutual exclusion. And in this case, if a process wants to enter the critical section, it will call this function and pass in as argument a function to be called, which would be, let's say, the critical section itself. And then this will start off the procedure of distributed mutual exclusion request with this trying to send exactly this event request. And now I can code each response to an event with a function by that name. So in this case, this is just because this is a very well-known thing, just to say what would happen. I will check my priorities and see if I can answer OK to go or not. So in this case, I will trigger the event OK to go back in the other process. So
Okay,
this is
small. This is how I like it. It's just a desktop model which can render the face or render an emotion, and its purpose, studying human-robot interaction. And our major goal is just to build showing you the editor. So I'm going to open an animation called Angry.
So at the top is our virtual ICAD that we created. And here at the left you have an embodiment definition where we have several variables like the left ear has a light with the red, green and blue variables. We have an eyebrow, an eyelid, stuff like that. And then here we have like a normal keyframe type of animation for each type of variable. Yeah. So I can show you this animation. It's not a biggie, it's angry, but yeah, it doesn't show up too well because it's looking down. You have to imagine that this thing is sitting in front of your desk, and we actually use this when our development machine gives an error on our software, it gets angry. Okay. So these variables we added to our Lua engine. Where is it? No. Okay. Try to find out. Okay. So what we did using that, this is our iCat, but we also have several other, like an iSpot and the RoboSapiens. I don't know if you know the RoboSapiens robot, but it's from a company called Huawei, which creates robots. We get it a little bit bigger. Oh, there you go. So now you see that instead of a keyframe editor, what we have here, which is pretty static, you cannot control anything in there anymore while you're playing it. This is like behavior, and this is just Lua script. You have a require in there, and let me see where it is. We have a produce next frame function, which gets called every 10th of a second, no, 100th of a second, right? 10 times a second. That's it. And you can see here that you have these variables like RoboSapien, waist, tilt, and you can just change the value using sinus and stuff like that. So this makes it pretty easy to create some nice stuff. So here you see the RoboSapiens wobble a bit. This is, I don't know how to tell it in English really, but it's like these strings pulling it.
Yeah.
Like, yeah, you tell it.
In the field of animation, you have pre-scripted animations and procedural, and with that you can simulate natural systems or physical systems. And what you see here is that each joint is being modeled by a spring, mass, damper system.
That's it.
And
Yeah.
they also influence each other. So
Yeah.
if one part moves, also the other part will move.
Yeah, so it's a spring mass system. So if I would, so moving the cursor actually just puts force on the system. And then I'm not doing anything, but it's naturally reacting to all the forces that have been put on there. And the hand's opening up, and that's part of the robot. When it moves one side, it will open up its hands. So this is a nice part that we now have for our animations, which is much better than the static animations.